Salutations, fellow enthusiasts. I'm here to showcase a system I designed, part of my project, Godot, which I'll get into soon. I'm Ethan LaRue. I'm a programmer. That's about it for now. The background of this project is that I was inspired by finite state machines and dependency managers, researched state design pattern on the Godot documentation, and Godot as a built-in state machine. Yet I have more research to do on that topic. Godot being the free and open source video game development engine. From what I've gleaned, the system that I'm designing is not really a state machine. It doesn't achieve the same goals as a state machine. So, what is my system? An easy way to explain is rather by example, and I can get into the high level concepts later. The example goes so. Let's create a scenario, a platforming game where we have a player character. The player character is able to be in particular states, and to start off with, we have three states: idle, running, and jumping. And let's define these states logically. Idle would be the state of a player character being still and not moving. The state of running is the state of moving to the right quickly, and the state of jumping is moving upwards and downwards, like you'd probably imagine jump in real life. These three states are all mutually exclusive, and it's easy to distinguish between them. You may either be idle or running or jumping. The idea is implementable code-wise with a variable storing the name of the current scene. So in this example, a variable stores the string value idle, running, or jumping. Now let me advance this example. I add the states walking and moving. And let's define these logically too. In addition to idle, running, and jumping, moving is the state of moving in any direction, just moving. And walking is the state of moving to the right. And to distinguish it from running, it's moving to the right slowly. Taking a look at walking first. While close to running, it is distinct. So it falls nicely into the paradigm of having one state variable at a time. It's one of the least problematic of the newly introduced states. But moving is more abstract. Moving is not mutually exclusive with all the previously introduced states. Moving is distinct from idle because idle is specifically defined to be when the character is not moving. But a problem is present when trying to distinguish it from the states walking, running, and even jumping, because those states require the player character to be moving in one way or another. So it's difficult to put these states in an either or set of cases. Our paradigm of having one state variable for all the states has become problematic. What are we able to do instead? A solution is to have a Boolean value for each state representing whether the character is in that state or not, that being true or false respectively. Taking the solution now, our characters are able to be in multiple states at once. E.g., you can be both moving and running, or moving and walking. So, you could actually envision these states as tags. To bring another thing into the mix is implications, prerequisites, dependencies. Walking, running, jumping, they all imply moving. There'd be none of those without moving. Appropriate to say that those three states depend on moving to be true, so we are able to draw links between them. But would there be no moving without running? No, there may be moving even if the character is not running. Moving does not explicitly imply running because the character could be moving in a different way. Therefore, the dependencies act in one direction. So, for example, if running is true, moving is required to be true as well. But if moving is true, running is not required to be true. However, the inverse is also a factor to consider. Reverse dependencies come into play as well. State of moving doesn't explicitly imply the state of walking, running, or jumping. Though if I wanted moving false, it would imply being neither walking, running, nor jumping. So if running is false, moving isn't required to be false. But if moving is false, running is required to be false as well. Now for a slightly different yet related story, a couple of what ifs over here. What if a state depends on multiple states to be true? What if a state depends on another state being false? E.g., being idle implies that the character is not moving. What if a state depends on what if a state depends on at least one of a set of states to be true? These what ifs embody the and, not, and or operators. Now, what if this intricately connected network of dependencies looped in on itself in a cyclic fashion? For example, we have a tag depending on another tag, depending on the tag, depending on the tag that it originally was. You're able to handle all these manually. That would make it tiresome manually setting all the required states to true or false respectively. So I automated it. These problems take more than a bit of code to solve, and I'm happy to say I've designed a system aimed to solve these problems. I'm cautious though, not saying my code is perfect, and additionally, my code is up for review and contribution since it is open source. So this is a good segue to really address my project. Here's my GitLab repository. The project's name is Godot. Let me go ahead and open it up. Okay. Whoops. Yeah, that's enough tabs for me. So my project's name is Godot. It's not the tag system alone. It's an entire game that I'm working on, as you can see over here. But the system is one of its focus points. So provided here is the URL. It's GitLab megaguy32 go algutage. Probably add the link in the description. And you may browse the code, and if you find you'll find the relative tag-based system code under the directory scripts tag classes. So let me go click over here. Scripts tag classes. Scripts tag classes, and here you'll find the relative tag-based state system code, and you'll also find an example implementation under scripts player character PLC tags. So let me just open that there. Player character PLC tags. There we go. You'll find the example implementation. I'll get into all this eventually. It's some code, but I'm just giving you the high-level explanation for now. So this is what I've created. It's a tag-based state system. It's to help a developer keep track of what state a character, a player character, or enemy, or whatever object you want in a state. It keeps track of what state the character is in. Character being a player character, enemy, inanimate object, or other, depending on how one implements the solution. And more truth is, I'm not sure exactly how to explain this because it's more of a problem that I'm solving, and I'm not too clued up on how to explain this to you. But maybe you can help me with that. But with that, I feel safe. I feel it's safe to stop things here. And next time we check in, we'll be able to get into some spaghetti and mince. Okay, I'm going to be walking you through an example implementation of my system. But alright, that's that. Peace for now.